Okay. As discussed in chapter 2, virtually all comparative, sorry, I can't say this, contemporary computer designs are based in concepts developed Yon, by John Niemann at the Institute of Advanced Studies. Principal design is referred to as Niemann's architecture and is based in three key concepts. One, data and instructions are stored in a single read-write memory. The contents of this memory are addressable by location without regard to the type of data contained there. Execution occurs in the physical fashion from one instruction to the next. The reason behind this concept was discussed in chapter 2, but it was summarizing.
Sorry, I was trying to mute someone else. Sorry. Please unmute yourself and continue.
This is a small set of basic components that can you go up?
Okay.
That can be combined in various ways to store binary data and to perform arithmetic and logical operations on that data. If there is a particular computation to be performed, a configuration of logical components designed specifically for that computation would be constructed. We can think of the process of connecting the various components in the desired configuration as a form of programming the resulting program. Is in the form of the hardware and its same hardwired program. Now consider this alternative. Suppose we construct a general purpose configuration. This set of hardware will perform various functions on data depending on control signal applied to the hardware. In the original case of customized hardware, the system accepts data and produces results as it is in figure 1A. General purpose the system accepts data and control signal and process results and produce results. Thus, instead of rewiring the hardware for each new program, the programmer merely needs to supply a new set of control signal. How shall the control signal be supplied? The answer is simple, but sublet or what? Sublet. Huh? Sublet.
No, sub
The
2,
entire
sub
program.
2, sub 2. The B is silent.
Okay, okay. I am seeing double T or double L.
No, it's B that is there.
Okay. The entire program is actually a sequence of steps. At each step, some arithmetic or logical. I think I'm trying to figure out this explanation. I'm not getting it at all.
Is there anybody that understand that part? What is that part talking about? Anyone to help us with the explanation? Starting from here. Nobody. They mentioned the man here, John Newman. And once you see names like that, let's try to be careful and see what was said about the name. because those are things that are funny questions that they normally ask in the exam. I just pray my network will allow us tonight. So this man made a design for okay, someone is raising hand. I see that. Oh, I see. Do you have something to say? If you have something to say, go on. Okay, I think that's an error. So, Newman, John Newman, gave a design, and the name of his design was called Your Newman Architecture. Don't forget no matter how we are studying in this course, bear something in mind. We are only talking about the architecture of computer, how computers were designed, both in and out. We want to know the architecture of computers. So this man is one of the contributors to the architecture of computer, and his own architecture was called or named John Newman architecture. The main concept behind his own architecture, his own design, just like now they asked 3 people to come up with a design that okay, this the way we are saying lap, you can see that we have several designs of laptops in our days. Several designs. It's not only one particular design of laptop we have. That is when you now start having mini, midi, big, medium, and the rest. You see several designs of laptop. So the design given by John Newman was called John Newman architecture. And he did his design based on 3 concepts. The first one is that his design works with data and instructions. His design works on this principle that data and instructions are stored in a single read-write memory. That's the first thing. Then the contents of this memory are addressable by location without regard to the type of data contained there, which means by knowing the location where a memory is, I can find the content without having to, look for the name of the content that is in that memory. I can use the location of the memory to trace the memory, even without without knowing the content that is in the memory. Now, or the type of data, whether it is audio, image, or video that is there. Now, execution occurs in a sequential fashion unless explicitly modified from one instruction to the next. Now, that is all on your Newman architecture. That's the design he gave. And those are the 3 principles or concepts his design works on. Now, please, it's very good to digest this thing. If you can't digest it in this class, do so personally yourself. Because once you see a man's name and they gave something under the man like this, those are potential questions. So, data and instruction are stored in a single read-write memory. Content of the memory are addressable by location, and then execution occurs in sequential fashion. Those are the things you need to know. Data and instructions are stored. Okay, let's read it together. Everybody, unmute yourself. Let's read the 3 concepts of John Newman architecture together. 1, 2, go. Data and
Data
instructions are stored
and
in a
stored
single
in
read-write memory. The
the
concepts
content
of
of
this
this
memory
memory
are addressed by
is
location
addressable by location
without regard
without
to the type of
regard
data
to the type of data
contained
contained
there.
there.
Execution
Execution
occurs in a
occurs in
sequential
first fashion
fashion. That is okay.
unless
Once you know that, it's okay.
explicitly
Execution occurs in a sequential fashion. That is enough. So we have done justice to that man's design. We now go to something else here that says that if there is a particular computation to be performed, a configuration of logic component designed specifically for that computation could be constructed. What we are saying is that sometimes some of these structures that we have, some of these designs that we have they are like an answer to a problem, a solution to a problem. They've seen that what this statement is trying to say is that if there is a particular, for instance, if you work, assuming you work in, let's say, in an oil company, and there is a part of your operation that seems to be consistent, like it used to reoccur. Now you want to design a computer architecture that can handle that easily. Now, because there is an operation on ground already that you want to design a computer to solve, then the design becomes easier because you work based on the problem that is on ground. Now, that's what they're trying to say here, that if there is a particular computation to be performed, a configuration of logic components designed specifically for that computation could be constructed. So using the problem on ground, you can use logic to create solution, but that solution can be computed. That is turned into a computer software or even a computer to handle this thing for us. Now we can think of the process of connecting the various components in the desired configuration as a form of programming. Normally, when you have a challenge like that you want to solve using logic, what you are to do next is just to program. That is a simple thing. It's programming. And the result, or when you are programming, what you are actually doing is to give out a program that will solve a problem. That program becomes a solution. So the result is a program, and it's in the form of hardware, and is termed a hardwired program. The idea of architecture is that we are not talking of software like designing an app. We are talking of designing a hardware for a particular problem. For instance, if they say that blind people want to be using computers, and then we have to use the Braille method to formulate a computer architecture that will be easy for them to, read on. Now, for us to design that kind of computer, we already have a computational problem on ground that we want blind people to be able to operate computer. Now, how to now design a computer that will function in that direction is what we call programming. And this programming is not like the software that you are programming. This one is dealing with hardware, and we'll call it hardwired program. So please, let's bear that in mind. It's very important. And I think we'll pick a lot in that place if we will not talk much here. Okay, as much as we have specific purpose, we also have general computational hardware. As much as we have those that are working for specific purposes, we also have those that are working for general purpose. So now there is a diagram here that we need to study. My network is here again. There is a diagram here we need to study, I think. How shall control signals be supplied? The answer is simple but subtle. Now, what's the meaning of subtle? I need someone to tell us, because we met it then. The person reading asked us a question, we only pronounce it. So what's the meaning? Yes, someone? What's the meaning of subtle? When something is subtle, is it that it is soft, or it is hard, or it is whatever? So what is the meaning? You better start learning grammar and vocabularies now before exam come. Yes. If you don't know, you check. What is the meaning? Someone should tell us. My network is a fuse tonight. I think we'll stop on this diagram. I don't know what's wrong with. But I'm not hearing you, or it's from my side.
Understandable.
Subtle means something that is immense, something comprehended, something
Okay.
simple.
Simple, soft, comprehensible. Okay. Thank you all. So let's see. Now, the entire program is actually a sequence of steps. At each step, some arithmetic or logical processes are involved. I think That's what they want to write there. Oh, sorry, I've jumped too much. Operation is performed on some data. Now, we mentioned sequence the other time. If you remember, even in the John Newman architecture, there was something mentioned there that talked about sequence. I think that was the third thing there, sequence of something, that the data are processed in sequential order or function, whatever. Now,